Okay, just a real quick review of identifying slope and y-intercept from a graph and then writing the equation. And if you notice, I tried to make these all nice whole number y-intercepts so you don't have to do any math for the red or the purple. And then of course the dark blue and the turquoise one, those are those special cases. Which function up here, or which relation up here is not a function? Number 4. Number 4 is what kind of line? Vertical line. It fails the vertical line test. It fails its own test miserably. So all of these are functions except number 4. What's the equation of number 1? There you go. Y equals -2. What is the slope of number 1? 0. What's the domain of number 1? Domain is the x's, the left and right edge. What do you see on the left and right edge? Arrows. That means it goes on for ever. So the domain is all real numbers. Most domains of lines is going to be all real numbers. There's an exception though when you've got one of those vertical guys. Range is a little bit different. Range is usually all real numbers as well if you've got a true line, except this is a special line. What's the range of this guy? I'll give you a hint. It's already showing up here. Not all real numbers. -2. The only y value you're ever going to land on, no matter where you land, the y value is -2. The x's go on forever, but the y's are one thing, -2, which is exactly what its equation was. So you got to know all that stuff for those types of lines. All right, how about the turquoise one? I'm sorry, not the turquoise, the purple one, number 2. Let me highlight some points for you. I know it's kind of hard to count from your seat or from your screen zoomers. Y equals -1/3 x plus 4. Are you guys with me? A lot of kids accidentally report this as y equals 1/3 x plus 4. They forget this is going down. So I would always look at my line before I even start trying to figure out the equation. Remind yourself this is going down and over, down and over. The slope better be negative. And yep, the y-intercept is 4. What's the domain of this guy? All real numbers. Look at the left and right. I see arrows. What's the range? Look at the top and bottom. What do you see? Arrows. It's all real numbers. Most lines, domain and range is going to be all real numbers. A normal slanted line with arrows on the ends, domain and range should be all real numbers. Number 3, a nice steep line. What's the equation of number 3? Y equals up 3 over 1. Y equals 3x plus 1. What's the domain of that? All real numbers. What's the range of that? All real numbers. Okay, and then the last one, the outlaw line, the one that doesn't follow any rules, the one that's not a function, the turquoise one. What's the equation of that weird turquoise line? X equals 5. That's why nothing about it is normal. It doesn't even have the letter X, Y in it. It starts out with an X. It doesn't have a y-intercept. It doesn't have a slope. What is the slope of this? What do we usually call it? Undefined. What's the domain of this? Now remember, domain is all of the x values. Wherever you land, what's your x value going to be? 5. The domain is x equals 5, just like the equation is. What's the range, though? The range is all real numbers because the y values go on forever. It goes up and down forever. And range is your y values. Okay, so there's Ariel. Nice little review for finding the equation of a line. Of course, we just wrote it in slope-intercept. What else could you do if I asked you to? Standard and point slope. Very good. But I'm not going to make you do that. I want to get on with systems of equations. Okay, a couple of things I want to point out. I was looking at assignment number 13 and 14. Remember, that was technically assigned last 6 weeks, but I have not put them in the grade book yet, and some of you have still not turned them in. 13 and 14. 13 was about parallel and perpendicular. 14 was about linear functions. This is going in the gradebook at the end of this week. Tomorrow, in other words. So if you haven't done these assignments, you need to make sure you go back and do them. And these are still able to be edited. Remember, this 6 weeks, I'm going to try some different things. I'm not going to let you edit your homework assignments. Are there any questions on just glancing through this, parallel and perpendicular lines? Because the next time you see it, it's going to be on a quiz, probably tomorrow, that you will not be able to edit. Please don't be shy. I'm having more kids come to tutoring. That's a wonderful thing. You can zoom into tutoring. If you're at home, you can zoom into tutoring if you're here. No questions on number 13. And then don't forget also number 14. I just saw 3 people from this class haven't turned this in yet. This was kind of the same thing, review of parallel and perpendicular, and then I had added a bunch of questions at the bottom. This one had 20 questions. Some of these are super easy. This was from the day that I was out, so I tried to give you some easy questions. Like, look at 17. What is 1 plus 1? Please don't miss that. These are easy. What's the y-intercept? That's just looking at the graph. Number 19. What's the slope? So please get that done. 3 of you haven't done it. And if you didn't do it, make a good grade on it, then redo it until you do. Okay, so that's one thing I wanted to talk about. Another thing I want to talk about is yesterday's 5 questions that I gave you. Again, we're trying something new here. You were supposed to make sure you did these. If you're not practicing these, guys, it's never going to sink in. Algebra is a participation sport, not a spectator sport. You can't watch. So, let's look at the answers to these. I'm going to let you check your own, and then if you didn't understand something, this is the time you better ask questions, because the next time you see it, it will be on a quiz that you cannot edit your responses to. All right, number 1. The answer to number 1 should have been 4, 8. The answer to number 2 was 5, 3. And that's exactly how I would want you to type it in, with no spaces or anything, but with parentheses as an ordered pair. The x number first, comma, y number, close parentheses. Number 3. My magic book is telling me 2, -2. Number 4. I've lost it. What did y'all get for number 4? 4, 2? Let's see if that would work. 12 minus 8 is 4. 4 equals 8 minus... Yep, it's 4, 2. Okay, I'll go over them in just a minute. And then number 5, what did y'all get for 5? 1 what? 1, 1. 1 equals 4 minus 3. That's true. 2 minus 5 equals... That's true. 1, 1. Except 3? Okay, so let's look at 3. 3 did have a little bit of a trick to it. So these were all rigged for you to be ready for substitution. It's ready for substitution if one of your equations has one letter all by itself. So this top equation meets that criteria. Y and 2x minus 6 are the same thing. That's what equals means. So this y right here, it's going to come completely out. There will not be a y anymore. What am I going to put in its place? 2x minus 6. This y will not be there anymore because I'm replacing it with 2x minus 6, since those two things are the same thing. Now, look what was in front of the y, though, before I took it out. A minus sign. That's important. If you're replacing y with more than one term, you have to put it in parentheses. You have to. So here was my problem. X minus y equals 4. I'm taking the y out and putting 2x minus 6 in its place. This minus sign has got to go to everything that's replacing the y. That's why you got to put it in parentheses. Just get in the habit of always putting in what you're replacing, put it in parentheses. Because this negative sign is going to change everything that's getting subtracted. So that's gonna become x, this 2x is now a minus 2x when I bring it out of parentheses, and the minus 6 is going to turn into a plus 6, and that's why you needed those parentheses. Otherwise, the minus 6 wouldn't get changed, and it's supposed to. And then just keep solving. X minus 2x is negative 1x plus 6 equals 4. Subtract 6 from both sides. Negative 1x equals negative 2, and you're not quite done yet. X, you got to divide by negative 1, so x just equals 2. Okay, so now that I know x equals 2, then I'm going to go back to either one of my original equations, and I'm going to replace the x number, or the x letter, with the number 2. I'm substituting again, but this time I'm substituting in one of my answers. So look at the top equation, y equals 2x minus 6. I know that my x value is supposed to be a 2, so I'm going to take the x out and put a 2 in its place. And I end up with y equals 4 minus 6, and that gives me a y value of negative 2. And then I can write my whole answer. All right, anything else on the warm-up? Or, I'm sorry, the homework. The homework from yesterday. Okay, hold on one second. I have a question on number 4. Let's do number 4, and then we'll go back to number 1. All right, number 4. X is the same exact thing as 8 minus 2y, right? So this x is going to come out, and I'm going to put 8 minus 2y in its place. What do I have to do with that 8 minus 2y, though? I have to put it in parentheses. So I had 3x minus 4y equals 4, but this x is going to come out completely and be replaced with 8 minus 2y. And I have to put it in parentheses so I can multiply the whole thing by 3. 3 was multiplying by x, so whatever I put in for x is also going to get multiplied by 3. So I got to distribute here. 3 times 8 is 24. I have to distribute that 3 to the minus 2y. That's why those parentheses are necessary, because that's going to turn it into negative 6y. And if you didn't put the parentheses, then that negative 2y wouldn't have changed, and it's going to give you the wrong answer. You did what? Oh, okay, that's what a lot of kids are doing. There should not still be an x in the equation. That's the whole point. We're taking the x completely out and replacing it with 8 minus 2y. We need an equation that only has y's in it. You shouldn't still have 2 letters. Once you do the substitution, you should only have 1 letter in your equation. Either x's or y's, it just depends. Alright, so now I have negative 10y plus 24 equals 4. Subtract 24 and you get negative 10y equals negative 20. So y would be 2. And then take that y value back to either of the equations. Probably this one would be the easiest. So x would equal 8 minus 2 times 2. 8 minus 4 is 4, and then you have your whole answer. Okay. Somebody else had a question about number 1, you said? Okay, I think you said you got the y-intercept wrong. I think you mean you just got the y value wrong. Yeah, we're finding the x and y value where these 2 lines intersect, right? Okay, y and 2x are interchangeable. So this y is going to come out. There will not be a y anymore. What do I put in its place? 2x, because y and 2x are the same thing. So instead of x plus y equals 12, I have x plus 2x equals 12. That's what I need, is an equation with just 1 letter in it. X plus 2x is 3x equals 12. And 12 divided by 3 is 4. So it sounds like you had that part right. So x is definitely 4 for number 1. Now we need to figure out what y is. Well, go back up here. Take out this x and put what in its place? 4. So y equals 2 times 4. And 2 times 4 is 8. So there's my x, there's my y. Wrap it in parentheses, and I am done. Alright, how did y'all do with the rest of these? Keep in mind, next time you see it will be tomorrow. I was going to do a whole another lesson on substitution where you had to rig it yourself. These were already pre-set up for you to where you could just plug it in and start substituting. But I've changed my mind. Substitution is not my favorite way, so I'm just going to go to my favorite way of solving systems of equations. Most kids like this way better. Sometimes substitution, though, is easiest. Sometimes this method is easiest. This is called the addition method. I forget. What was the last one? It was just, I thought it was just 1, 1, isn't it? You got 1, -1? Okay, let's try this one real quick. X equals 4 minus 3y, right? So this x is coming out and 4 minus 3y is going in its place, and I have to put it in parentheses. So instead of 2x, I have 2 parentheses 4 minus 3y, and then rewrite the rest of it, minus 5y equals -3. Distribute the 2. That's 8. Minus 6y minus 5y equals -3. Combine your like terms over here. -6y and -5y. That's -11y. So 8 minus 11y equals -3. Get rid of this 8. That 8 is positive. So I'm going to subtract 8 from both sides. So then I have -11y equals -11. And then divide by -11, and y is +1. Okay, let's get to the new method. I think you guys will like this. Now, it's going to seem very easy at first, and you're going to be mad that I didn't just show you this yesterday. But keep in mind, these first few are definitely rigged to where this is going to be a super easy way. This is called the addition method for systems of equations. So we're still talking about two lines. We're trying to find the one point where they do what? Where they intersect. Okay. Are you ready? Here we go. X plus y equals 6. That's one of my equations. X minus y equals 12. There's my other equation. What form are both of those equations in? Standard form. So guess what? With the addition method, your lines need to be in standard form. Jashara, I would try to follow this with us now and then like do that later, because I don't want you to get behind of what we're doing now. I mean, I'm glad you're getting caught up, but I don't want you to get behind on this. Okay, so for the addition method to work, they do need to be in standard form. Now, what do you notice about the y's? Look at the coefficients of this y. What's the coefficient of this y? What number's in front of that y? 1, +1. What number's in front of this y? -1. That's important. Those are exact opposites of each other. Look what happens when I add these two equations together. What's x plus x? 2x. What's positive y and negative y? What happens to those? They cancel out. Yeah, there's no y's left at all. So I'm not even going to bring down the y's. They canceled out. What's 6 plus 12? Now I've got an equation with just x's. So what does x equal? 9. We already have half our answer. X is 9. How do you find the y? Because remember, I'm looking for a point. A point is an x number and a y number. So far I know the x number. How am I going to figure out what y is? Yeah. You got to take that 9 and either put it into that equation or that equation. It doesn't matter. Wherever you see an x, you're going to put a 9. 9 plus y equals 6. What would y equal? -3. I also could have done it right here. 9 minus y equals 12. Subtract 9, you get -y equals 3. Divide by -1, you still get the same y answer no matter which equation you use. So what's my point then? 9 comma -3. All right, let's try another one. Number 2. -3x plus y equals -3. Positive 3x plus y equals 9. What do you notice about the coefficients of the x terms? They're opposites. They're exact opposites of each other. And if we added these two equations, the x's would cancel out. Quang, are you writing these down? Okay, so that's what makes addition method so easy. But I'm telling you, these first few problems we're doing, they're rigged to where it's already set up to where something will cancel out immediately. But that makes your life so easy. Let's add these two equations together. What's negative 3x and positive 3x? They cancel each other out. I don't even need to bring down the x's. What's y plus y? 2y. And negative 3 plus 9 is 6. So what does y equal? 3. Now I take that y value back to either of the original equations. I'm going to use the bottom one. 3x plus y equals 9. I just figured out that my y value where they intersect has to be a 3. So I'm going to take the y out and put a 3 in its place. Subtract 3. 9 minus 3 is 6. What does x equal? 2. So then I write my answer as a point, wrap it in parentheses, and that's it. Y'all like this better? Okay, you try this one. Number 3. 3x minus 2y equals 2. 7x plus 2y equals 18. So is this already rigged for addition to work here? How can you tell? The y's have exact opposite numbers as coefficients. A negative 2y and a positive 2y, if I add those up, they're going to cancel right out. And that was the whole point of substitution as well. You want to create an equation where you've only got one letter, so that you can find out what half of your answer is, what your x or y is. And if I add these two together, the y's cancel right out. So when I add these up, what do I get? 10x equals 20. The y's canceled out. So what does x equal? 2. Am I done though? Now I still have to find the y. So substitution is always involved somehow, some way. The second step is always substituting your answer you got. In this case, we got an answer for x. So wherever I see an x, I'm going to put a 2. I'm going to go back to my top equation that said 3x minus 2y equals 2. I just figured out that the x value of my answer is a 2. So instead of 3 times x, I'm going to do 3 times 2. Well, that's 6 minus 2y equals 2. What do I do next? Subtract 6. Yeah, move that 6. I got to subtract 6. Now I have negative 2y equals negative 4. What does y equal? So in this case, my x and my y number were the same. That's just a coincidence. Okay, this time I'm really not going to say anything. I'm going to let you do number 4. I'm going to pause the video. You find both the x and y. Is it ready to be added? Yes. How do I know it's ready for the addition method? Yeah, because the x's, I can tell the x's have exact opposite coefficients. That means something will cancel, and that will make my life so easy. All right, I'm going to stop. Show me with your hands what you got for the y value. That's what you'll get first. Good, good, good. Yes, yes, yes. Now, the harder part, though, is plugging in that y value and finding the x. Oh, I think the x is going to be a fraction. Oh, maybe not. No, it's not. Never mind. But it's a number that freaks you guys out sometimes. forgot to pause. Oh well, okay. Add these together. The x's are going to cancel right out, right? And I know they're going to cancel out because they have opposite coefficients. Negative 7x and positive 7x is 0 x's. I'm not even going to write it down. This is an invisible 1y plus a 3y, which makes 4y. And 1 plus 3 is 4. So my y value is 1. So I know half of my answer. I know the y value where they intersect is a 1. Take that 1 and go back to any of the two equations that you started with and take out the y and put in a 1. I'm going to go back to this one. So instead of negative 7x plus y equals 1, I'm going to put negative 7x plus 1 equals 1. I took the y out and put a 1 in its place. Now, just follow your rules for solving equations. I've got to make that positive 1 go away. How do I do that? Good. So now I have negative 7x equals 0. Divide by negative 7. What's 0 divided by anything? 0. So my x value was 0. So these intersect at 0, 1. What's special about this point? What is this point called? No, the parent function is, that's the y-intercept. So these two lines intersect at their y-intercept. Try to say that fast 5 times. They intersect at their intercept. They intersect at their intercept. Nobody wants to try it? Just me. Alrighty. Alright, number 5. Now, those were all rigged for you. Let me show you one that's not rigged, and you're going to have to rig it. Are you ready? 4x minus y equals 7. 5x plus 3y equals 13. The nice thing about this is it's already in standard form. The addition method, your lines really need to be look like they're in standard form. At least have x's and y's on the same side. Your x's and your y's and your equal sign, they all need to be lined up underneath one above the other for this to work. Okay, if we add these together, is anything going to cancel? No. So as this looks right now, it's not going to benefit us all at all to add these two equations together. Nothing's going to cancel. However, remember, you can do anything you want to an equation as long as you do it to the whole equation. Zoomers, are you still there? Zoomers, we had a little power surge or something. Can y'all still see me? I think I'm muted. Y'all can still hear me and see me? Or see the board?
No, I can't hear you, but I can hear.
You can see the board, though?
I can't see.
Oh, it stopped screen sharing. Okay. Here we go. How about now? Can y'all see the board now?
Loading. Well, yeah.
Okay, here we go. Alright, I was saying we can't add these together. We could add these together, but it won't do us any good. We would get a whole new equation and nothing's going to cancel, so it's not really going to do us any good whatsoever. So we have to figure out something else we could do. Look at the y values. Do you see how this has a coefficient of 3 and this has a coefficient of negative 1? Wouldn't it be nice if there was a negative 3 in front of that y? Because if there was a negative 3 here, it would cancel out with a positive 3. Do you see what I'm saying? Well, I cannot just go around changing a negative sign to a negative 3 because I want to. But what I could do is I could multiply that whole top equation by 3. That's perfectly legal. It will not change the value of the equation at all. It'll still be the same line. It'll just look a little bit different. And that's legal as long as I multiply every single thing by 3. So I'm going to create a new version of that top equation. What's the new version of my top equation? 12x minus 3y is equal to 21. If one thing is going to change, the whole equation has to change. You can't just change one little part of an equation. That is not mathematically legal. But I certainly can multiply the whole thing by 3. It's the same equation. It just is like it's like an unreduced fraction. It's an unreduced equation. And that's perfectly fine. And now look, when I add the old bottom equation and my new top equation, now the y's will cancel. And I would get 17x equals what? 34. And x equals 2. 34 divided by 17 is 2. And again, if you need a calculator to do the 34 divided by 17, that's fine with me. Am I done though? No, I still need the what? I still need the y. I could go back to original equation number 1. I could go back to original equation number 2. If I wanted to, I could even go back to the new equation, the version of number 1 that I changed. But I've got to pick an equation somewhere and take out the x and put in a 2. I'm going to go back to the original top equation where it said 4x minus y equals 7. I'm going to put a 2 in for x. What's 4 times 2? So now I have 8 minus y equals 7. And now I got to solve that little baby equation. The 8's got to go to the other side. How do I make an 8 go to the other side? Minus 8. So now I still have negative y equals negative 1. Still not quite done. If negative y equals negative 1, y equals 1. So these lines should intersect at 1, 2. And I haven't been checking my answer, but you could always check these. Oh, 2, 1. I was just making sure you're paying attention. Good job. 2, 1. And I haven't been checking my answer. That's a common mistake, by the way, so don't do what I just did. Make sure you put your x first and your y second. Let's check it. I'm going to put a 2 in for x and a 1 for y. 4 times 2 minus 1, it better equal 7. Well, 4 times 2 is 8, and 8 minus 1 is 7. It works on this line. Let me put it on this one. Put a 2 in for x and a 1 for y. 5 times 2 is 10. 3 times 1 is 3, and 10 plus 3 sure does equal 13. That's the one point that's going to work on both equations and even the new version that we made. Okay, I'm going to give you 5 problems to work on. These will be due when? Tomorrow. Bring them with you tomorrow, please. Already worked out. Number 1, some of them are already going to be set up, rigged for you, and all you got to do is start by adding them together. Is this one already rigged for you? Yes. In fact, you know what? I'm just going to make them all rigged. How about that? I won't even make you do that multiply step. We'll practice some more of that next week. Okay, I'm going to go ahead and, well, never mind. I was going to stop the video. I'm going to post all of these on Google Classroom, so you will have the questions available and the video that we're recording right now. If you need to watch it and pause it, and if I went too fast, then you can watch it at your leisure. Okay, so tomorrow we're going to go over these answers, and tomorrow I will have a Google form, kind of like a little quiz. Zoomers, you must be present in the Zoom with me tomorrow, and then this is going to be like one of your first major grades of the new 6 weeks. Okay, so those are already nice and rigged for you. We'll practice more next time with where you have to actually rig it for yourself. But these are all good to go for the addition method. Add them up, something will cancel. then you have to plug that answer back in to find the second part. Yeah, are y'all clear on what you're doing here? 5 questions, I'm gonna give you the rest of the period. These shouldn't really take as long as the substitution method did. These to me are a little bit easier. All right, good luck.